Okay, so this isn't going to be too long because, like I said, I just want to go up to page 17 with you all. But I do want you to go through this because it's going to be really important. I don't know how you guys feel about the exam. And depending upon when you watch this video, you don't know if your grade was posted yet. But even if, you felt comfortable in doing well, you really want to make sure you read ahead. And just not understand everything. I'm not expecting you to understand everything in the section that we haven't covered yet, but at least be exposed to it. Okay, so just keep that in mind. Okay, so we talked about Gaussian elimination, and so now this is Gaussian elimination with back substitution. And so the term echelon refers to the stair-step pattern formed by the non-zero entries of the matrix, okay? And we talked about that stair-step pattern, right? And to be in this form, a matrix must have the following properties. So row echelon form and reduced row echelon form. Those are two different forms that we're going to be dealing with. And row echelon form is actually what we dealt with in the previous section. So a matrix is in row echelon form, has the following properties. 1. Any row consisting entirely of zeros has to be at the bottom of the matrix. Okay. 2. For each row that does not consist entirely of zeros, the first non-zero entry must have a leading 1. Okay. And 3. For any two successive non-zero rows, the leading one in the higher row is further to the left than the leading one in the lower row. And reading that, sometimes you're like, what's going on? But basically, the key is to remember you must have a stair-step pattern. Okay, so that's saying if there's a leading one in row 2, then in row 3 you can't have. So what I'm saying is, let's say we have 1, 2, 3, 0, 1, 4, and then 0, 1, 5. So this is not in so the first two conditions, actually, and this is a pretty nice example. I just made this up. Very good. Okay. So the first condition is any row consists entirely of zeros occur at the bottom. We don't have a row of zeros, so we're good there. 2, any row that does not consist entirely of zeros, the first non-zero entry is a leading 1. That's the leading 1. This is a 0 entry, but the first non-zero entry is 1, and the first non-zero entry here is 1. Okay, so conditions 1 and 2 are actually met with this matrix. However, condition 3 says for any two successive, so one after the other, rows, or one below the other, I should say, the leading one in the higher row is further to the left than the leading one in the lower row. So that means you can't have it right underneath. So we would have to, so this is not in row echelon form. We would have to do some of the elementary row operations to get it in row echelon form. Okay, so that's what I mean there. And then a matrix, so that's row echelon form, those three conditions. And then for reduce, and sometimes we call this REF and then RREF. Okay. And so for reduced row echelon form, a matrix in row echelon form is in reduced row echelon form when every column that has a leading 1 has zeros in every position above and below it. And that's something a little different. Okay. And that's why I'm going to stop it at slide 17, because we're going to go over it, more in class. And if you have questions, but really do make sure you look ahead to see if you get sort of an understanding. So, well, this one, and if you're not in row echelon form, then you can't be in reduced row echelon form, right? So we could stop there. But what's reduced row echelon form is saying, since there's a leading 1 here, this needs to be 0 and that needs to be 0. Okay, and we're going to talk more about that next week as well. Okay, so it's worth noting that row echelon form of a matrix is not unique. Okay, what does that mean? It's not unique. Well, that means if you and your friend in the class or another classmate, if you're doing the elementary row operations differently, then in row echelon form you may not have the same things. So don't think you're wrong if you don't have the same matrices after getting it in row echelon form. Okay, so that is two different sequences of elementary row operations may yield different row echelon forms, okay? However, if it's in reduced, yeah, we really need space here, row echelon, so RREF form, that is unique. So if you get it all the way down, so it's worth getting it all the way in reduced row echelon form. Although I might ask you just to do row echelon form sometimes, but because it's unique. And then you can easily check your answers when you're working on these together. Okay, so the last slide that we're going to go over in this video is just looking at some examples. So again, the first condition says if there's a row of 0, so in A there's not a row of 0, so we're good, right? The second condition says, and this is again from slide 15, for any row this does not consist entirely of zeros, the first non-zero entry is a 1, right? So that's a 1. The first non-zero entry is a 1, and the first non-zero entry is a 1 here. Okay, so it satisfies the first two conditions. And then the third condition says any two successive, so beneath. So if you have, looking at a leading 1, right, then there can't be a leading 1 below here. Okay, and it's not, right? That's all it's saying. So this is a leading 1, so it can't be a leading 1 below here. And then this is a leading 1, and it's done. So there's nothing below that. So this is in row echelon form because the first three conditions are met. However, it's not in reduced row echelon form. And just think about it. Why do you think that is? So pause the video and think about why isn't this in reduced row echelon form? Okay, welcome back. You should have figured out it's not in reduced row echelon form because that needs to be a 0 as well as those terms need to be a 0 in order for it to be in reduced row echelon form, RREF. All right, so it's in REF, but it's not in RREF. Okay, let's look at B. So B, we don't have a row containing all of zeros, so condition 1 is met by default. Any row that's not leading 1, so we have leading 1s in every row. So in each row, the first non-zero constant is a 1. And below it, there's no, so here, that's what we're looking at. That can't be a leading 1, right? Or here as well, those can't be leading 1s, and they're not. Okay, so it's in row echelon form, but it's not in RREF, reduced row echelon form, because, you guessed it, that needs to be a 0 and that needs to be a 0. Okay. And notice here too, so notice we're looking at the leading ones, right? The leading ones in the rows. We just have three rows. So the leading ones in each row, because we're looking at row. This is row echelon and reduced row. So we're paying attention to the rows, not the columns, the rows. So be careful with that. Okay. C is in reduced row echelon form. So that means it's definitely in row echelon form, right? So just check yourself to make sure those three conditions are met. And then check to see, well, why it's in reduced row echelon form, because what? Well, here's our leading ones, and above and below each of the leading ones are zeros. Okay, so I hope that makes sense. And then in D and E, we have reduced row echelon form and reduced row echelon form in both of those. So here we actually have, so that first condition, any rows consisting entirely of zeros must be at the bottom. So that's what that means. Okay, so that's an example of that. And then you can go over the other rows. All right, we are done with this video. Again, although I'm stopping here at page 17, I want you, how many pages? In this notes is 29. So just sort of skim it through and get exposed to it, but we're going to finish it on Wednesday, so I'm not going back over anything in these slides. So go back over the video. If you have questions, you can email me. You can come see me on Tuesday. I'm going to send out an email for my office hours on Tuesday, but otherwise we're going to move on from slide 18 on Wednesday.